Okay, this time we record. And we're going to do the share screen. Okay, so this is the second notebook we are going to went over. And for the second one, the first part we are going to discuss is use some function or mapping to do some data transforming, because that's also part of the data cleaning you will see later on when you do your data analysis. Okay, so let's take up an example. So we first create a data frame with dictionary. Okay, and this dictionary, the value part is a list, and we have two key, food and ounces. Okay, so that's the first part. And the second part we have this dictionary. Okay, this dictionary is regarding the mapping of meat to animal. Okay, and for this one, what we did is we convert all of the food part, because if you take a close look, you will find in some of the word, it's all lowercase, but some of it also have the uppercase. So that's why we want to make it all consistency. So we cause lower to convert off the food part to the lower case. And here we use a function, we call it a map, the map function. So what this map function, what it does is it will map the values from two series. Okay, and we have meat to animal series. This is a series, is it the series? And all the key part serves as a label, because in pandas series, the difference between it versus the regular arrays, it's a labeled array, is it? Yeah. And so that's this part. And the food part, the lowercase one, it's from this food part. Is it the food dictionary? Okay, and in this food dictionary, we have all of the meat word. So over here, we have one series from food. We have the other series from the meat to animal. So we are going to do some mapping, is it? And with that mapping part, we add it to a new column for our data frame, and we call it animal. And what we have, this data now looks like, if you take a look, is that previously you only have two columns, the food column and the ounce column, is it? And here we add the third column. The third column is we get from this series, is it? So that we map the corresponding meat to the corresponding animal. Okay, so we add the third column with the result from the map. And we can also over here do the map, call this map function again. Okay, and the plug in with the map, what we did is we have the lambda function. And for this lambda function, it's pretty straightforward. What it did is it's just to get whatever the animal, is it, from the meat, is it, because the meat is the key part, is it? Yeah, so you can see, yeah, it did find the corresponding mapping part, is it? So the map function here, we see it's quite useful, okay? And you can also plug in some lambda function to the map. And over here, a lot of time, you can also do some replace. Over here, you change this specific Nova logs to a new name called the salmon. So you can call the replace. Oh no, we change it to a oh, we change the name. So here the NP we replace it with yeah. So we replace that Navalox here to name. So you can also call the replace function, okay, to change some value to a new value that you need. And for the next one, what it shows is we can also rename the axis index. And I remember in our previous example, we learned how to rename the column, okay? And here it says you can also rename the index label, okay? So we have a new data frame. So it's regarding like the state, is it? And we have some values, random number generated. And it's pretty straightforward. And here we have this transform. This transform is a function, okay? And it's defined by our lambda expression. And what it does is, okay, it tries to retrieve something from a collection, is it? And convert that collection to only retrieve from the first four items from the collection. So in this case, it's a string. So get the first four letters from the string and convert it to uppercase. Okay, so this is our transform. And then with our data frames index label as it, and we can call the map function. And then we are going to map the original label to this transformed with only four letters, and also all of them are the uppercase. Yeah, so if you take a look, yeah, so here's the result. It shows the new index meet this transformation. And then over here, so we did the mapping. Okay, we did the mapping. And if we take a look at our data, then you can see the index did get changed. It's all uppercase, is it? And with only four letters. And we can also use the rename function. So the rename function, and then you can specify with the index and with the column. Okay, and in this case, it said, oh, the index, we are going to use the title. If you take a look here, the string title, is it? And the previous one, this data frame, is it? The index is all uppercase, is it? All uppercase. And here you change, you rename it with what we call it a string title format. So title, it's only the first letter. It's only the first letter is uppercase, okay? And all of the other are lowercase. And you also want to change the column, is it? In the previous, all lowercase, is it? And over here, we change it to all cap. Is it? So to change the column to all uppercase. So you can also call the rename function and specify its index or column with whatever the new value you want to have. And the next, what it shows for the rename is you can also use dictionary to change the name. So over here, it says, okay, I want to change the Ohio to Indiana, is it? And change 3 of the column name to a new called Peekaboo. So you can also use the dictionary to do renaming. And what next shows, I already mentioned, is this option, the in place option. So if you do want all of the modifications have occurred on your original data, then you need to put this in place option as true, okay? Otherwise, it won't impact on your original data. So in this case, it's on the original data, so in place is true. And what the next part shows is, because a lot of time for your data, you may want to do some categorization, is it? And with categorization, you want to do some distribution with discretization and the bin count, is it? So how are we going to do this? So let's take a look. So we have this list for age. And then over here, we have another list, okay? And with this list, and over here, we call pandas, we call it the cut, is it? So what this cut method is going to do is, it's going to return, it's as a special category object. Okay, and if we take a look, what it returns, the category object is, it looks like something like this. Yeah, looks something like that. So what this 18 and 25 and the 25 to 35, where it comes from? It comes from our second list, is it? The second list, basically what it serves as the bin. Okay, serves as a bin. And so the result, so what it did is it's going to put the age value, so 20. So 20 belongs to the bin 18 to 25, is it? So that's why this 20, what the result shows, the corresponding, the categorization is, oh, it goes to this bin. Okay, and then let's take a look, the fourth one, 27, is it? So 27, it belongs to the second bin, 25 to 35, is it? So let's see, 1, 2, 3, 4, is it? So the first one, yeah, it does give you back this bin, this category. So what here is trying to show is with this cut function, if you specify the list of items that you want to categorization, and if you also provide some corresponding bin that you are going to do categorization, what the result going to give you is your value will fall in which specific bin. Okay, so that's what that is. And the other, there is a method called codes, is it? So with this codes, what you can get is, you also want to know, okay, regarding in that bin, which index location it is it? So this codes will return you that. So with this bin, we have 4 bins, is it? We have the first one, second one, third one, the fourth one. We have these 4 bins, is it? So that's why you see, it will give you the bin index. Okay, so that means the first age 20 fall into the first bin. The second 22, age 22 also fall into the first bin. So with the codes, it will also give you the index location of your items. And you can also get the categories of your category data returned by the cut function. So what this cat's categories returns you, oh, it will tell you, okay, what each specific bin is, okay. And value counts, previously we already learned, is it? It's will give you the frequency, okay, and the output is also sorted. So in this case, because we have the category data, is it, with each bin, so it will count the bin's frequency, for each bin's frequency. So how many of that bin the result fall into specific bin, how many times, is it? And so with this value counts of our categorized object, and we can also get the result of their frequency in each bin. So with the value counts. And what the next one shows is here it says consistent with mathematical notation for the intervals. Is it? So in the pandas, so it's a match what the mathematical definition. So if it's a parenthesis, that means the side is open, okay? And with square brackets, it's closed, so it's inclusive, okay? So over here, what it shows when you call the cut with the age, is it? And you can also specify if it's left open or if it's right open. Is it? Over here it says, okay, for the right, I don't want it to be inclusive. Is it? So I want it to be open. So that's why you set right as false. Then it will make it open. Okay. So that's regarding whenever we discuss intervals, if we want the left or right be inclusive or not, then you can use this option of left and right. And what the next one shows is, it says you can also use name for your bin. Okay, and with pass in the list or array of the name options. So over here, we have a list of string, is it? And when you call the cut function, and if you have your label point to this list of strings, then for your categorization result, what you will get from this label. So instead of the interval, what you will get is a corresponding label. Yeah. So that's also quite useful when we do the analysis. What the next part shows is you can also specify the precision when you do the division. Okay. So over here is so how many bins you want to divide with a certain range of numbers, is it? So over here it says, okay, I want to have 4 bins. Okay, and you can also say, oh, I want to have 5 bins, is it? Okay, and then what will be the precision when you do divide by the bin with your number? Is it? Here says, okay, it's will go to decimal 2 points, is it? So so that's how the result shows. We have the data. So the data is from oh yeah. So the data is some random number we generated. Is it random number generated, and then we are going to have the categorization. Is it categorization? And over here we specify we're going to just have 4 bins. Is it? So we didn't specify its left inclusion or right inclusion. Is it? So by default, the left side is open. Is open, and then it's going to place of the random numbers, is it, in each of the bins. So that's what we see here. And with what's the next one is not the cut. Here it's called Q cut. Okay, so what's the difference between the Q cut and the cut? Is it? So what a cut does is you have certain range, and then you're going to evenly divide the range. Okay, you're going to evenly divide the range. And what a Q cut it does, it's cut based on quantiles. Okay, quantiles. So if we cut as 4 quantiles, so what that means is you're going to have 25%, 50%, 75%, and 100%. So you're going to have those 4 percentage. So it's more evenly distributed if you have a certain number of items. then it will have 25%. The first 25% go to the first quantile, the second 25% go to the second quantile, the third 25% go to the third quantile. So like this. So in this case, suppose if we have 1,000 numbers created, and if we do the Q cut with 4 bins, then we will have 250. So we will have 250 numbers in each of the quantile. Yeah, so in this case, then you will have evenly distributed numbers in each of the bin. And what the next one shows, a lot of time you may want to filter out certain outliers for your data, is it? So in this case, how do we detect and filter out outliers? So here it shows the examples. So same thing, we generate some data frame, is it? And here it shows the data frame with a certain number. And what here you want to do some filtering, and we learned before you can use Boolean condition, is it? So over here it says, okay, all absolute values greater than 3, is it? We want to get them out. So then in this case, you can apply this condition with your data. And then what over here it shows, okay, I want to just to get with any one, in case if there is any one value that's meet that condition, and we want to select that row, okay, then in that case, you can do something like apply that any method and with the condition. And what the next part shows is over here, we also call the sign, okay? So what the sign here does is it gives you +1 or -1. So the sign value will show you, okay, based on this condition, if it is true or not. And if it is meet the condition, it's going to assign 1. And if it's not, it's assign -1, something like that. And then in this case, I also wanted to triple it. So you can times 3, is it? And then you will get -3 or +3. So that's what we have. And then over here it shows, is it based on that data, then you can call the NP the sign, is it? And here is what is the header part. So the first couple of numbers shows. So yeah, based on the condition, you will get 1 or -1, is it? That's what you assign. And the next one shows we can also do some permutation, okay, and some random sampling. So here we have some numbers generated, is it? And then we are going to do some permutation. Then you can call the method permutate 5. So the output, if we take a look, you will see it's not arranged by from 0, 1, 2, 3, 4, 5 by the order, is it? It's permutated among the 5 numbers. So you can also call this. And we can also call sample to pick a certain number of random, so here subset, is it, without replacement. Then you can call the sample method. Okay, and the next one, this is very, very useful, the dummy variables. Okay, it's quite useful. Especially when you do, later on, when you want to do some statistical modeling or you want to do some machine learning, then the dummy values plays a very important role, okay? And with the get dummy functions can help you to achieve that. So let's take a look. So the first, we create a data frame. So it's pretty straightforward. It has 6 rows and 5 columns. And over here, then if you take a look, so we retrieve the first column, is it? So the first column, the data has ABC, 3 values. And here you call pandas get dummy function, and you apply the pandas get dummy function to this specific column. And what we will get if you take a look, it's kind of the specific column. What the value it has A, B, C, is it? But A, B, C not numerical value, they are string. Is it? And then what is the get dummy function is, they will get the ABC, the string, is it? Two column. So basically you have three column, is it? And with the three column, then the corresponding one, let's take a look. The first row, the original key is B, is it? So yeah, then what the get dummy will return you as 1, because you do have B. Is it? So if you do have that value, then that corresponding row and column intersection, then the value will be 1. So that means, okay, in the original column, B is in the original column. Okay. And if you take a look for A and C, both of them are 0. That's because in the original column, it doesn't have A and C for the first row, is it? And for the second one, let's take a look at the third row. For the third row, for the original column, we have A, is it? So what this get dummy returns you is the corresponding A column, it has 1. But the corresponding B and C, it has 0. Yeah, so that's because the original A is in the original column, but B and C are not. So that's why when the get dummy returns you, it returns you 1. Okay, and why we need this is because a lot of time when you have data you collected from like internet, it may be string. Okay, but when you want to do some modeling, especially we do the statistics model or machine learning, and the machine learning, it needs a number value to apply to certain math model. So we need a number. And then in that case, what we can do is you can convert the original 1 column data then into 3 column data. And this 3 column, we call them dummy data. And the 3 column, how they get to the 3 column is from the original, the value from the column, and you convert them to as a column, as a new column value. And then you can have 0 or 1 or some other value that you can specify, okay? Okay, so the get dummy function is quite useful, okay, when we deal with non-numerical data, and then you can convert non-numerical data and expand it to a new number of columns, and then have numerical data. Okay, so let's see over here. And we have our original data frame, is it? We have the key, is it? And it says, okay, we are going to call the get dummy function, is it? And here it says, oh, you can also add some prefix for the newly added dummy column, is it? And then with our newly created 3 column, this 3 column, and we also have the prefix. So here what it means is you add the prefix, so key, add it ahead of it. So that's called a prefix. And then you're going to add this new data frame to our existing one, etc. And what we are going to have, you will see, oh, you're going to have this new data frame. And then this new data frame, it has this 3 new columns, it's ABC. But basically this ABC comes from where? If you compare with the original, it comes from a specific column's values. So that's what the get a dummy, the dummy value means. So dummy value can convert from non-numerical to numerical values, okay? But it will expand the number of columns of your original data frame. And then what the next part it try to show is we are going to use the dummy values to deal with another movie data. Okay, so this is another movie data, and this movie data is not a CSV file. So the separator, the delimiter is a double colon here, okay? And it only has 3 columns: movie ID, movie title, and movie genres, okay? And it all, the genres, it's all strings. So if we take a close look of the first 10 records, we can find, like for genres, for the first one, it has 3 genres. It has animation, it has children's, and it has comedy, etc. So can we like separate them? Because this is all in one genre, etc. Belong to one genre. And when we do some data analysis, assuming like if you want to do frequency counting, like the get value, etc. And then if you have all these 3 crumbled together, it's not easy to do. Then you need to do the string analysis. So it's going to be hard. So if we can borrow the dummy values, then that's going to help us a lot. So let's take a look. So what we are going to do is we are going to loop through all of the genres, and we can call the strings split function, and you specify the delimiter as a vertical. And then we are going to create our list, So over here, because the split is going to return a list, so you call list extend function, so it will add the newly list to the end of the all genres list, And then you can call unique function to only get the unique genres from this all genres. It may have the duplicate values. Okay, so then we are going to have this unique function will have all of the only original ones. And then next, let's see, how do we have some new data frame with all of the detailed movie genre information there. So over here, first we create a 0 matrix. Okay, so it's a big matrix. It has the same number of rows as our movies, and it's based on the genres. Okay, and the genres, we already make our genres specific to each specific genre. And then we are going to create our data frame with this of the 0 values. So that's our data frame, straightforward. And then next, let's see. Over here, let's see, we what we did first is we take pardon me?
I think we're over our time.
Oh, we are already over. Oh, okay. I'm sorry, I haven't finished it completely. So what we are going to